There's a moment that anyone who has used a coding agent will recognize, and it is a good place to start because it quietly reveals how these systems are actually built. The agent has been working through a task. It reaches the point of running a command, and everything stops to ask whether that is allowed. It is completely natural to read that as the model pausing to ask permission. That is what it looks like, and nothing in the interface suggests otherwise. But something slightly different is happening, and the gap between what it looks like and what it is turns out to explain a great deal. The model did not stop. A token predictor produced a block of text describing a command it would like run, and a separate piece of ordinary software holding the credentials, the file handles, the shell, read that text, recognized it as a request for something privileged, and paused to get a human answer. That surrounding software is called a harness, and it is worth getting to know, not because anyone has been careless in overlooking it. The vocabulary genuinely works against you here, and the products are designed to make it invisible. But nearly every question people find confusing about AI systems has an answer that lives in the harness rather than in the model. Start with the smaller of the two, because it is genuinely simple. A large language model is a file of numbers and a function that runs them, several hundred gigabytes of weights, and a procedure that takes a sequence of tokens and returns a scored guess at what comes next. Three things follow, and each one tends to surprise people, because each contradicts what the chat window implies. The model is stateless. It retains nothing between calls. It is frozen. Your conversation is not teaching it anything, and its entire action space is emitting tokens. It cannot read a file, query a database, or call an API. Hold on to that last one. A good deal follows from it. Part of what makes this hard is that the words are overloaded, and not deliberately. The industry grew quickly, and the vocabulary did not keep up. Claude means at least three things. There is the model family, the weight files. There is the product, the chat app, the desktop app, the coding agent, software systems that contain a model roughly the way a car contains an engine. And there is the persona, the character that introduces itself, which comes from written instructions in the input. When someone says the AI read their document and summarized it, every verb except the summarizing describes the product. That is not imprecision on their part. It is what the naming invites. The picture needs to get more accurate here, because calling the harness the thing that passes text to the model undersells it considerably. Ask a coding agent to fix a failing test. Before any code is touched, most harnesses make a call whose only job is to produce a plan, break the request down, decide what to inspect, choose the tools and the order. That planning call is a complete round trip on its own. You never see its output. The harness keeps it as working state. Then it starts executing, and every step is another call. Read the test file, another call to interpret it, search the code base, propose an edit, run it, interpret the result. What felt like one question can easily be 5 or 15 round trips, and between every one of them, the model remembered nothing. Each call arrived at a stateless function with no knowledge of the one before it. That sense of an agent holding the thread, recalling that it already tried something and should try something else, is the harness maintaining state across a series of independent amnesiac consultations. The model supplies judgment, one call at a time. The harness supplies persistence, which brings us to the most interesting thing the harness does, which is decide what to remember. Because the model is stateless, every call has to carry its own context. The harness resends the conversation each time, which is why it appears to remember your name from 4 turns ago. Your name is sitting right there in the input, every single time. Memory is not something the model has. It is something the harness performs by resending. But it cannot resend everything. Context windows are finite, tokens cost money, long inputs add latency. On every call, then, the harness makes a judgment. Recent turns in full, older stretches compressed to summaries, some material dropped, documents pulled in because they seem related. That selection is an algorithm somebody designed, and almost everything people describe as the system's memory quality is really the quality of that selection. When it feels sharp, the harness chose well. When it seems to forget something, the harness dropped it. The model did not forget. The model was never told. And this is where it genuinely looks like learning. Start a new session and everything resets. No history, no context, back to the beginning. That reset is the clearest evidence that nothing was accumulating inside the model. Newer products soften it by reaching into prior sessions, saved project files, earlier chats, pulling forward whatever seems relevant now. And the effect is striking. It appears to know you, to have kept your preferences, to have gotten better at working with you. But the weights are byte for byte identical to what they were before any of those conversations happened. What improved is the harness's selection of what to carry forward. If anything here is learning, it is the harness, and in a specific limited sense. It is accumulating prior material and getting better at cherry picking which pieces belong in the next call. That is a real capability and worth appreciating. It is just not the thing it appears to be, and the distinction starts to matter the moment you ask what the system is allowed to pull forward and from whose material. The third thing the harness does has the sharpest consequence, and it follows from everything so far. The model cannot act, but it can describe an action, so the harness reads that description, performs the action itself, and appends the result to the context for the next call. The harness executes the action. Every privileged operation an AI agent performs is carried out by conventional software, running with conventional credentials, because a text generator asked for it. The model holds no privileges of its own, not reduced ones, not sandboxed ones. The harness holds all of them. That is not a criticism of the design. It is the correct arrangement, and it turns out to be good news, which makes one common situation much easier to see clearly. Vetting a model family is real work. It also covers the least variable part of the system, a chat window with no tools and a coding agent with shell access and repository write permission can run identical weights and share very little in terms of risk. Everything that changed between them is harness. Which tools are exposed, what credentials they carry, how much prior context they can pull forward, who has to approve a write. A review scoped to the model will not surface those, not because it was done poorly, but because it was pointed at a component that does not have those properties. The encouraging part is that the harness is ordinary software, deterministic, inspectable, testable, and subject to every access control discipline we have spent 40 years building. There is no need for a new theory of security here. It is mostly the familiar work, applied to a component that has been sitting slightly out of view. The next time an approval dialog interrupts an agent, it is worth seeing it for what it is, not a model showing restraint, a moment where the harness surfaced a decision it was making anyway. It makes hundreds of others silently. What to plan, what to remember, what to carry forward, and from where. Being able to see them is most of the work.